Welcome to lecture number 5. Today we will discuss Castigliano's first theorem as well as Castigliano's second theorem. So, first we will discuss Castigliano's first theorem. Let us say U is equal to total strain energy of the system. Small un is equal to displacement at point n and Pn is equal to load at the point n. So, as per Castigliano's first theorem, the first partial derivative of total strain energy with respect to displacement is equal to load at point n in the direction of un. Right? So this is our Castigliano's first theorem. If you remember just this expression, then you can write this expression in words. So what we can write here, the partial derivative of the total strain energy with respect to the displacement is equal to external load Pn at the point in the direction of the displacement. This Castigliano's theorem is applicable only for linear elastic structure if the supports are unyielding and temperature is maintained constant. Means if the temperature is changing and if there is support settlement, then we cannot apply Castigliano's theorem. We will see what does this linear elastic mean. We all know the Hooke's law. Stress is equal to Young's modulus of elasticity into strain. If you plot this relation, stress versus strain, if the curve is a straight line, then this material is known as the linear elastic material, right? But let's say the curve is like this, then this is not linear elastic, this is non-linear. So hope you get idea what is linear elastic material. Now what does unyielding support means? Let's say we have a fixed beam, and if this beam settles by some amount delta, in that case deflection pattern will be like this. Then there will be additional moment m. So if there is any additional moment due to settlement, then we cannot apply this relation del u by del u is equal to Pn. Here capital U is the strain energy and small un is the displacement at point n and Pn is the load at point n. Now we'll see Castigliano's second theorem. As per this theorem, the first partial derivative of total strain energy with respect to the load at any point n is equal to displacement at that point in the direction of the load. So this is the second Castigliano's theorem. Again, this equation is applicable for linear elastic material and supports unyielding support, and if the temperature is constant, then only apply this theorem. Statement: the first partial derivative of the total strain energy with respect to any external load, that is Pn, is equal to the displacement of the point of the application of load in the direction of applied load. Now we will see the proof of Castigliano's first theorem. Let us say we have a structure AB. We have some supports in between and we have different loads applied. P1, P2, P3, Pn, and like this, Pn plus 1, something like this. And this is the displacement. Let's say at point 1 we have displacement u1, at point 2 we have displacement u2, at point 3 we have displacement u3, at point n we have displacement un. So what is this strain energy? This strain energy capital U can be written as half of all the loads Pi into all the displacement Ui. Means here we can write U is equal to half of P1 U1 plus half of P2 U2 plus half of Pn Un. Remember, in last slide we have seen that this theorem is applicable only for linear structure. Why this is so? This is because we have written strain energy as half P1 U1, half P1 U1. Right, we can write half P1 U1 only when the structure is linearly elastic. Now we can write P1 is equal to K11 U1 plus K12 U2 in the same manner plus K1n Un. Let us generalize this relation as Pi. We can write Pi means I can be anyone, 1, 2, n. Right, Pi we can write as Ki1 U1 plus Ki2 U2 and so on Kin Un, where this Kij, these terms is known as the stiffness coefficient. These terms is known as the stiffness coefficients. Now what is this Kij? Let's say we have a beam and we have 2 points I and J. So this load at I point to generate unit displacement, this is unit 1.0. Load at I point to generate unit displacement at J point is known as the Kij. Right. So using this relation we can say Pi is equal to this whole expression. Now we put the value of P1, P2, P3, Pn in this equation. Then what we will get? We will get U is equal to half of U1 into this term 1n Un plus, in similar manner if you do P2 in this equation, we will get half U2 K21 into U1 plus K22 into U2, same manner K2n into Un, half of Un Kn1 U1 plus Kn2 U2 Knn Un. Right, now we differentiate this expression with respect to U1. Let's say del U by del U1 is equal to, these all are U2, U3, U4, so partial derivative will be equal to 0. We have to differentiate only this term, it will be equal to K11 U1. Get the second term, again contribution of all these will be equal to 0. We will get K21 U2 plus, in the same manner we will get kn1 un. From Maxwell reciprocal theorem, what we know? Kij is equal to kji. So if we put k21 is equal to k12, then this whole term will be equal to this pi, right? So what we can write? Del u by del u1 is equal to p1. This is the Castellanos theorem that we have to prove. Hence proved. Now we will see Castellanos' second theorem proof. We already know u is equal to half of p1 u1 plus half of p2 u2 plus half of pn un. In first case we have replaced the value of p1, but now we will replace value of u1. This u1, u2, u3 means ui can be written as ai1 p1 plus ai2 p2 plus so on ain pn, where ai1, ai2, ain means aij is known as the flexibility coefficient. Now we will put value of u1, u2, u3 in first equation. We will get u is equal to half of, in place of u1 we will write a11 p1 plus a12 p2 and similar manner a1n pn plus half of, then we take p2 out, and what is the value of u2? u2 will be equal to u21 p1 plus u22 p2 plus same and u2n pn. Similarly, half of un1 p1 plus un2 p2, similar manner pn. Now we rearrange the terms and we will get u is equal to half of a11 p1 square, this term plus this term plus this term, right, plus a22 p2 square plus a33. In this manner we will get ann pn square, plus again rest of the term like a12 p1 p2 plus a13 p1 p3 plus a1n p1 pn. Now we will do del u by del p1. What we'll get? We'll get a11 p1. There will be no contribution from these terms because there is no p1 term here, so differentiation will be equal to 0. Now in second case they will be equal to a12 p2, similarly a13 p3. So this term will be equal to this term, and this is equal to u1. So we will replace this as u1. So we'll have del u by del p1 is equal to u1. So for all I is equal to 1 to n, we can write del u by del pn is equal to un. where n is equal to 1, 2 up to n. So this is the proof of Castigliano's second theorem. Now we come at the end of this lecture. I thank you all of the students and the SemExcel team for writing all the questions on slide.